The Sun is the heart of our solar system. It is a giant ball of burning gas. Its enormous gravity holds our planet Earth in a stable and predictable orbit. Without this gravitational pull, our world would simply drift away into the cold and empty void of space. But the Sun gives us more than just a stable path to follow. It provides the light and warmth that make life on Earth possible. Every ray of sunlight that touches our skin is a packet of energy that travels millions of kilometers to reach us. This energy is the fundamental source of power for almost every living creature on this planet. It determines day and night, seasons, and Earth's climate. Think of the Sun as a cosmic power plant. It constantly emits an enormous amount of energy in every direction. Earth captures only a tiny fraction of this energy, yet it is enough to support everything we need. This energy warms the oceans, drives the atmosphere to create weather, and provides the light we need to see the world around us. From the smallest blade of grass to the largest whale in the ocean, all life is connected to the Sun. The Sun is a silent and constant partner in the dance of life, an anchor that provides stability, and the fuel that powers Earth's biosphere. Without the Sun, the story of life on Earth would never have begun. Our connection with the Sun is written into our own biology. The rhythm of day and night, regulated by Earth's rotation and sunlight, has shaped the sleep cycles of countless species, including ourselves. Seasonal changes, caused by our planet's tilted journey around the Sun, signal plants when to grow and when to rest. Birds use the position of the Sun to navigate during their long migrations across continents. The Sun even produces important vitamins in our skin when it is exposed to its light. Every morning, we are greeted by sunlight as an essential daily reminder. This light is more than just natural illumination, but it is a spectrum of energy in which sunlight is used by plants in the process of producing food and oxygen called photosynthesis. Through this remarkable process, they convert sunlight into chemical energy, forming the foundation of the food web that supports all complex life. The warmth provided by the Sun keeps water on the surface of our planet in a liquid state, where water is the most important element for the life of living creatures on Earth. The Sun is not just a feature in our sky. It is the architect, the supporter, and the primary source of power for our living world. Its presence is the most important factor for life on Earth. Imagine that right now, the Sun suddenly goes out. Such an event is scientifically impossible, but let us try to imagine it. On Earth, we would not immediately know it. Light, the fastest thing in the universe, still needs time to travel the vast distance between the Sun and our planet. This journey covers about 150 million kilometers, or 93 million miles. Moving at a speed of nearly 300,000 kilometers per second, sunlight takes about 8 minutes and 20 seconds to reach us. So for several precious minutes after the Sun disappears, our sky would remain bright, and life on Earth would continue as usual. We would live through that remaining time, completely unaware of the disaster that has already occurred. This delay does not only apply to light, but also to gravity. According to Einstein's theory of general relativity, gravity also travels at the speed of light. At the same time the last sunlight leaves the surface of the Sun, gravitational waves carrying information about this phenomenon would also begin to disappear. For 8 minutes, Earth would continue to orbit a ghost, an empty point in space where our star once existed. Then, at the exact moment the world sinks into absolute darkness, the gravitational influence would disappear. Our planet would no longer be bound to its usual path. It would fly straight ahead, becoming a wandering planet racing through the cold and dark emptiness between the stars. The darkness that would envelop us would be unlike any night we have ever experienced. It would be thick in total darkness. The moon, which only shines by reflecting sunlight, would become invisible. The planets we know in the night sky, such as Venus and Mars, would also disappear from view. The only remaining light would come from distant stars, which are far too distant to provide meaningful illumination on Earth's surface. We would drift in such dense darkness that you would not be able to see your own hand in front of your face. The sudden transition from a sunlit day to a star-filled emptiness would be the first terrifying sign that life on Earth has changed significantly and can never return to what it once was. With our planet now no longer bound by gravity and sailing into the endless cosmic ocean, our fate would be fixed in uncertainty for a very long time. Earth would become a lonely wanderer in the Milky Way galaxy. Indeed, the possibility of Earth colliding with another star or celestial object would be extremely small, considering the enormous distances between stars. Instead, our planet would be destined to travel through darkness for unimaginable lengths of time. The main problem would not be collisions with other celestial objects, but the rapid decline of temperatures on Earth's surface that our world would not be able to stop. What was once bathed in the warmth of sunlight would now be exposed to the terrifying cold of space, beginning a steady drop in temperature and heading toward a permanent global ice age. With the loss of the sun's warmth, the temperature on Earth's surface would begin to drop dramatically. This change would not occur immediately because the atmosphere and the oceans still have a large capacity to retain heat. During the first week, the global average temperature would fall to around 0 degrees Celsius or 32 degrees Fahrenheit. That temperature would be extremely cold. However, for some people who are used to living in cold places, it would feel like an extreme winter day. But the cooling process on Earth would not stop there. Without sunlight to warm the surface, the planet would continue to radiate its heat into space. Without stopping, temperatures would continue to drop beyond the freezing point, slowly but surely heading toward the coldest temperatures Earth has ever experienced. Within the first year, the global average temperature would plunge to -100 degrees Celsius or -148 degrees Fahrenheit. At this temperature, the oceans that cover more than 70% of our planet's surface would begin to freeze. A thick ice crust thousands of meters deep would form and bury marine ecosystems beneath it. Earth's atmosphere would also begin to change. As the planet becomes colder, the air we breathe would begin to condense. As temperatures drop to extreme levels, gases in the atmosphere such as carbon dioxide and nitrogen would change from gas into liquid and eventually freeze into solid form. These substances would then fall to the surface as solid particles resembling snow, covering the layers of water ice that had already frozen earlier. Earth would become a silent ball of ice. There would no longer be seasonal changes as before. Without solar energy, there would be no heat to evaporate water and no temperature differences in the air. As a result, winds would stop blowing, clouds would disappear, and rain or snow that previously fell continuously would stop completely. Weather on Earth would stop entirely. The sky would remain permanently clear, but completely black, filled only with the faint and cold light of distant stars. The familiar view of planet Earth that we once knew would be buried beneath thick layers of ice and frozen atmospheric gases. Earth would become a ball of ice, like some moons of Jupiter or Saturn that were once believed to have had life. This new frozen Earth would continue its lonely journey through the galaxy. Although its surface would be extremely cold, some warmth would remain trapped inside the planet's core. Geothermal heat, a remnant from Earth's formation and from the decay of radioactive elements, would slowly leak outward. The remaining heat trapped inside Earth might still be enough to keep water in liquid form in a few extremely remote places, especially around volcanic activity and hydrothermal vents on the ocean floor that are slowly freezing. In these extreme places, heat from inside the Earth would become the only remaining source of energy. But for the surface of the planet and all life that depends directly on sunlight, the end of a life cycle would arrive quickly and without compromise. The earliest and most decisive impact would be the stopping of photosynthesis. Photosynthesis is the foundation of complex life on Earth. It is the process that allows plants, algae, and various bacteria to convert sunlight into energy and indirectly feed almost every living creature. Without sunlight, this vital process would stop almost instantly. Plants act as the primary producers that support almost the entire food chain on Earth. When their ability to produce energy and organic material suddenly disappears, the effects would spread throughout ecosystems, triggering a chain of widespread extinctions. Within days to weeks, most plants on the planet would wither, lose their biological functions, and die. The world's great forests, from the Amazon rainforest to the Siberian taiga, would turn into silent landscapes filled with frozen trunks and branches, the final traces of ecosystems that were once fertile before eventually being buried under ice. The collapse of plant life would quickly cause mass starvation among herbivores, the animals that depend directly on plants as their source of energy. From small insects to large mammals like elephants, every organism that relies on leaves, fruits, and grass would lose its food supply. This event would trigger the next wave of mass extinction. Carnivores that prey on these herbivores would soon face the same fate, because the disappearance of prey means the loss of their energy source. The extremely complex web of life that evolved over billions of years would collapse in a very short time. Predators might be able to survive slightly longer than herbivores, but it would only be temporary. In the end, the sounds of life that once filled this planet would disappear, replaced by a cold and complete silence. Humans would not escape this crisis either. In the early stages, we might still be able to generate light and heat using backup energy sources such as fossil fuels, electricity, and nuclear power. However, all of these sources are limited and cannot replace the role of the sun in the long term. Sooner or later, those energy supplies would run out. The greatest challenge humanity would face is food availability. With the collapse of the global agricultural system, humans would depend on preserved food supplies such as canned food and emergency food stocks, which are limited and cannot be replenished. Some communities might survive longer in special environments such as geothermal-powered facilities or deep underground bunkers. However, such a life would be isolated, bleak, and far removed from the civilization we once knew. For most of humanity, surviving more than a few months to 1 year would be nearly impossible. Eventually, the only forms of life likely to survive would be simple microorganisms. Certain types of extremophile bacteria are known to survive without sunlight, deep beneath the Earth's surface or around hydrothermal vents on the ocean floor. These organisms obtain energy not from light, but from inorganic chemical reactions, using heat and compounds from Earth's interior. They might continue to survive, gathering around the remaining warmth slowly leaking from the planet's core, never realizing that the world above them has turned into a lifeless, frozen wasteland. Life on Earth would shrink into microscopic pockets hidden in darkness, a faint remnant of the once rich biosphere illuminated by the sun. The planet would eventually become a silent graveyard, a profound reminder that all life on Earth depends on one seemingly simple yet fragile thing: the light of a distant star.